Today's lesson is on how do we express numbers in scientific notation. A number in scientific notation is a product of two factors. The first factor must be greater than or equal to 1 and less than 10. The second factor is a power of 10. Take a second to copy down those notes. Let's complete this first problem together. The height of the largest waterfall in the world is 3,212 feet. Express this number in scientific notation. In order to express a number in scientific notation, the first factor must be greater than or equal to 1 and less than 10. 3,212 is greater than or equal to 1, but it is not less than 10. So I'm going to have to move my decimal point. There's an imaginary decimal at the end, 0.0. I'm going to move my decimal until I have a number that is greater than or equal to 1 and less than 10. I have to move my decimal 1, 2, 3 times. The number I end up with is 3.212. So that is my first factor. My second factor is a power of 10. So I'm going to multiply that by 10 times however many times I moved my decimal point. Since I moved my decimal point 1, 2, 3 times to the left, this is going to be times 3 times 10 to the third power. The second question. A mechanical pencil lead measures 0.005 meters. Express the measurement in scientific notation. Again, in order for the number to be in scientific notation, the first factor has to be a number greater than or equal to 1 and less than 10. 0.005 is less than 10, but is not greater than or equal to 1. So I'm going to have to start by turning this into a number that is greater than or equal to 1 and less than 10. I have to move my decimal 1, 2, 3 times to the right, and I end up with 5 times 10. Since I moved my decimal point 1, 2, 3 times to the right, this is going to be a negative 3. The reason why it's negative 3 again, this can become 5 times 1 over 10 to the third power, which then becomes 5 over 1,000. If I did 5 divided by 1,000, I would end up with 0.005. So it is the opposite of what you would think. If I am moving my decimal to the right, my exponent is going to be negative. If I move my decimal to the left, my exponent is going to be positive. And my last question. Write the following numbers in standard form. I have 5.78 times 10 to the 11th. This symbol represents the exponent. So I can rewrite this as 5.78 times 10 with an exponent of 11. The way to do this is I'm going to rewrite my number, 5.78. Since it is 10 to the 11th, I need to move my decimal point 11 places to the right. I'm going to start where my decimal is, and I'm just going to count out to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. My decimal point now is moved here. I cannot just have all these blank spaces, so however many blank spaces I have, I'm going to fill those all in with zeros. So this would be my new number. So I have 5, 7, 8, and then I have 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I add my commas where needed. I can also then check my answer to make sure that I did it correctly. Since it is 5.78 times 10 to the 11th, I would have to move my decimal point 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And since I end up back at 5.78, my answer is correct. The second problem, 2.32 times 10 to the negative 9th power. Again, I can rewrite this as 2.32 times 10 to the negative 9. Since I have a negative exponent, I know that my number is going to have to be very small. So I can rewrite my number, 2.32, and since it's a negative, I'm going to move my decimal 9 places to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9. My new decimal point ends up here. The same way I had to fill in the zeros before, I'm going to fill in the zeros after my decimal. 1, 2, 3, 4, 5, 6, 7, 8. So my answer would be 0.8 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 2. And if I want to check my answer again, I can go ahead and do that. Since it's 10 to the negative 9th, if I move my decimal point 9 times, I should end up with 2.32. 1, 2, 3, 4, 5, 6, 7, 8, 9. I get 2.32, so my answer is correct.